Hello, in this video we will talk about the test for equality of variance in ANOVA. So we know in ANOVA, for example, one-way analysis of variance, the test of F ratio will give the result of test of the assumption that all mean value from treatments are equal or not. But this test is based on the assumption that all the variance for the different treatment groups are exactly the same. And if the treatment groups comes from normal populations, and this assumption for the variance equality will be slightly not insensitive if this assumption is not met. But in many cases, and this is assumed that we have sample size equal for different groups. But in many cases, when the sample size is not equal, and the treatment groups are not exactly the normal, so it's very important to test assumptions that the variance are equal before we can do ANOVA test. So we have hypothesis H0 that all the variance are the same, against the alternative H1 that variance are not the same. And test method is called Barrett's test because we will use Barrett's distribution. So this distribution is not very often used, but it will be used for in test for equality of variance in ANOVA. So first, we will calculate all sample variance S1 square, S2 square for different treatment groups. And there we assume that the sample size is not equal. And N is all the sample size, just summation for N, I from 1 to K. Then from this sample variance for different groups, we can get a pooled sample variance SP, which is weighted mean for all group sample variance. So now there is a statistic from the data based on group variance and pooled sample variance. This is actually the power with the sample size for each group sample variance, then project together, then take n minus k, 1 divided by n minus k in the power. Then this part divided by SP square. So this value will compare with a critical value from the Barrett's distribution. So if this value from the sample less than this Barrett's distribution critical value, then we will reject the H0 at alpha level of significance. And this Barrett's distribution has one significance level and one sample size. So note that in Barrett's test we will reject H0 if this test statistic is located on the left side, on the left tail of Barrett's distribution. So this is left tail. Now this is a table for the Barrett's distribution. For example, there are 5 groups and N is 10. So Barrett's distribution has only one N. So next page we will show how to transform the different size data information from different Barrett's distribution. So only for the Barrett's distribution with only one parameter, sample size, and one critical level. So for this Barrett's table, this critical level is 0.01 and sample size, for example, is 10. So for the different groups, 5 groups, so we get this critical value 0.7352. So which means if we get the balance value B from the sample size less than this value, so we will reject the null hypothesis, right? And because for the left side of this critical value in the balance distribution density function, density curve, then about probability 0.01, right? So we will, for the different size case, the balance value from the sample less than the critical value from the balance distribution. But you know, balance distribution has only one sample size. So this bk alpha n1, n2, nk approximately equal to the weighted mean from different balance critical value. So B alpha 1, 2, nk equals n1 times bk alpha n1 plus n2 bk alpha n2 and so on, then divided by their total sample size. So this is the sample, this is the critical value we will compare it with, right? So we take a look at an example. Use balance test to test the hypothesis at the 0.01 level of significance that the population variance of the 4 drug groups are equal. So here we have 4 groups, so K is 4. And their size different for different groups. So although these two are the same, but these two are not the same as this one. So the solution, we will have the hypothesis H0 is all 4 groups have same variance. And H1 is the variance are not equal, are not all equal at alpha 0.01 level. So we have sample size N1 20, N2 and N3 9, N4 is 7. So total N is 45 and K is 4. Therefore, we will reject H0 if the sample B less than balance level 4, 0.01 and this 4 sample size. And this value can be calculated approximately with a combination of each of 4 balance critical value from the table. So we can find, for example, balance first one 20, 0.01 is about 0.8586. And this 4 balance critical value with sample size 9 and with a critical level 0.01. So combine this together, divided by 45, we get critical value of the balance is 0.7513 in this example. So if the sample B value less than this one, we will reject the null hypothesis, right? So next we will calculate the sample information. So all 4 group sample variance can be easily calculated. And the pooled sample variance can also be got from the combination of these 4 sample group variance. And we get the B value, which is power of each one, power of each sampled variance together, then take power of 1 divided by 41. Then divided by the SP for the pooled sample variance. So in the end, we get this sample B value is 0.85. Because this value is not less than the critical value we will compare it with. So the decision of this example is we do not reject the hypothesis and conclude that the population variance of the 4 drug groups are not significantly different. So, in other words, that we will accept the null hypothesis that the population variance from different drug groups are the same. We will hold this assumption. Thanks for watching.